Okay, so I want to get into polylines more in depth. I touched on them briefly in the beginner series, just showing you what a polyline generally is, but there's so much more to polylines than what I'd alluded to. And to start with, I want to show you something, and this goes for any command, but when initiating a command, and PL being the shorthand for P-line, which is a polyline, alternatively, you can click the icon here. When you're in a command, you can always hit F1 to pull up the help file related to whatever command you're currently in. And you can see all of the information here related to polylines. This kind of stuff is great because it gives you a way to slow down and process each aspect of the command prompts for polylines. There's a lot of stuff here, and everything you see here, or just about everything you see here, I'm going to go over right now, and then some things that maybe they don't talk to you about in the help file. So first off, what is a polyline? It is a group of lines or arcs that are connected together in a sort of group. So if I were to draw a few lines that make a triangle, each one of these line segments is individual. And if I move a line segment, it moves independently of the other segments. Whereas a polyline, in the same vein, creates a singular object. It's like a group of objects, but it's technically a singular object. When you look at it in the properties menu, it shows up as a polyline as opposed to a line, which shows up as just a line. And you can see the properties here on the for a generic line as opposed to the properties for a polyline, which look different. There's no more start and end coordinates or deltas, length and angle. You've got things like what your current vertex is. You can see it over here highlighting. You can select your vertex, and it shows you the vertex coordinates, your start width and ending width, and your global width and your elevation, and things like that. So there's a few things we can do here. That's a basic polyline. You initiate your polyline command. You draw as many segments as you feel you need to. They don't have to end. They don't have to close. They can just be open-ended. And then there you have your polyline. You can grab a grip and it will move a particular portion of that polyline. If you grab one of the corner grips or vertex grips, if you go to grab a center grip, it'll just move that entire segment as such. If you initiate a command on a polyline, it moves or it acts on that polyline altogether. So move, copy, even offset will offset that polyline as one entity instead of each individual segment. So that's the basis of it. Polygons are also polylines. So if you were to draw something with the polygon command, and let's say I give it 6 sides, and there's the center, I'm going to just leave it as inscribed. This is now a 6-sided polygon or polyline that creates a polygon. Rectangles are one of the easiest ways to make a closed polyline. Again, when you look at these objects, even if I select multiple, they're all considered polyline. If they were not all polylines, you would see nothing there because you have various types. You'd see all, and then it shows you the various types of objects you have here. So, all right, let's get into the options of what you can do with a polyline when you start creating it. So you know how you can create some quick polylines, whether they're open-ended, whether they're through the polygon tool or the rectangle tool. That's how you can create polygons. Let's start looking at some of the options. So we initiate our polyline command. We pick a start point. You have a few things you can do. You have arc, half width, length, undo, and width. Now, half width and width are essentially the same thing, with half width being literally half of whatever the width of the polyline should be. So let's say that I want to do a polyline with a width of 1. Well, mid-command, before I've clicked my next point, I can say width or W for width. And I can specify my starting width as 0, or sorry, as 1. And if I want it to be an even line throughout, I'll leave it as 1 for the ending width as well. Now I have a line with a thickness of 1. So as I start drawing, it maintains that thickness. I can change the width part of the way through to something like 2. Now every segment will have a width of 2. And so on and so forth if you want a multi-widths polyline. In addition to that, let's change this width back to 0. After I draw a line segment, I can choose to do an arc segment. Now, there's a lot of options with an arc segment that I'm not really going to get into, but they relate to the way you draw arcs naturally. It will attempt to draw just a complete arc with an endpoint, no defined radius here. What it's doing is just trying to fill in with what it thinks I want as far as my endpoint goes. In a lot of cases, you can draw arcs fairly easily. I'll show you how to do that in a second. You can also choose a center point. So instead of just a beginning and an end, you can choose where you want, say, your center point, and you can pick like from here. Let's see, center, CE. You have to clarify that. Center point arc can be here. And then now, because that's my center point, it wants to draw the arc in that way. There's a lot of different options. You can hold control to flip the direction. You can choose, you can just write the angle out if you want to choose what the actual angle is. I can say 30 degrees and it will attempt to do a 30-degree arc. There's a lot of ways where you can do this. One of the things that can be kind of confusing though is trying to generate an arc in a polyline ahead of time. So, you know, maybe it's easier instead of trying to make your polyline. Let's say you have a shape that looks like this. Okay, and maybe this part is like this. And I'm not going to put the exact definitions here. Okay, let's say it's some kind of a, you know, slotted hole for a picture hanger or something along those lines. You could draw this as a polyline straight up. But if you have your exact dimensions, let's actually do exact dimensions. Let's start at 0, 0. Say I have a circle with a diameter of 5. I'm going to copy this over, I don't know, 30. Put a circle with a diameter of 15. And it connects here. Right? I know I have these dimensions, maybe they were given to me. It's in a lot of cases easier to draw this with individual segments first, as opposed to trying to draw it from scratch with a P-line and doing the same thing, you know, trying to do this and then doing an arc and trying to make that arc work. But we want to convert this to a P-line because maybe it was easier to draft it in individual segments first and then convert it into a polyline, which you can do. So the way to convert a polyline or edit a polyline after the fact is to do what's called a polyline edit, a p-edit. I'm going to type this in, p-edit. It should be under your Modify tab. Let's see. It may be under one of these, edit polyline right here, p-edit. But I just think it's easier to put p-edit. When you select a poly or an object, a line or an arc that is not originally a polyline, it asks you if you want to turn it into one, and you can say yes. So I just say yes or enter. Afterwards, we have options that allow us to modify this polyline retroactively. Well, since I want to convert all of these, I don't have to actually go and convert each segment. What I can do after I've picked my first line segment or arc, I can choose to join. And I can select all the segments together. It says 3 segments added to polylines. We have 1, that's the arc here, 2, this line, and 3, this arc segment here. So now I have 3 segments that were added to this original line. I could just hit enter afterwards, and now what I've got is a polyline that's been converted from individual lines and arcs. Okay, so that's about converting, and there's more options that we can do. We can change the width and some other things like that. But let's get back to the Polyline command and see what else we can do. You can choose a straight up length. This might be better in combination with an arc, because if you're doing a length, unless you're doing it along a certain angle, if you're going along, orthogonal angles, you can just type in the length of whatever it needs to be. But if you're going along a certain angle, you can always type in the length. But even in that case, honestly, I just say do something like, less than 330 degrees, and it will lock you into that direction, and then you can type in your length that way rather than using the actual length command. So one of the things you can do lastly is, once you've got your first segment drawn, a new option comes up, and that is close. Because once you've drawn a few segments and you want to make sure that your last segment is going to connect to your first segment, you can just hit close. So I'm going to hit the close option here, and it will connect the last two lines. And that way you know for sure that you have a closed polyline. How do you know if you have a closed or open polyline? Well, if you look at a polyline, and now I'm going to make this one obviously open, and I go to do a p-edit, if I select this, it gives me the option to close it. Okay, whereas if I do a p-edit on this one, it gives me the option to open it. There will be times when a polyline looks like it is a closed polyline, but is in fact an open polyline. And this is actually quite important, because there may be certain functions such as the extrude command, which can be run on polylines. And the extrude command looks different on a closed polyline versus an open polyline. If you do an extrusion on, and I know this is more 3D, so if I'm catching you before we've gotten to doing 3D work, this may be a little out of your league, but bear with me. If I run an extrude command on a closed polyline, it will make a 3D solid. This is actually a 3D solid. If I run an extrude command on an open polyline, it makes a mesh or a surface extrusion. Very, very different. So, and again, it may be that you have a polyline that looks closed. This could be, extremely close, but when you're looking at it from far away, but it is actually not. I can join this to here, and it's not a closed polyline. If I go into my p-edit and I select it, it is in fact an open polyline with the option to close. So when I go and extrude this, I'm going to get a mesh. So if that happens, keep in mind that you probably just need to close your polyline. Okay, so now let's look further into the p-edit command. So I've got my polyline here. I'm going to do a p-edit and choose. I have options, and let me go back one step real quick. When you run the p-edit command, it is possible to do a p-edit on multiple objects, and you can actually do a multiple convert. If you have multiple lines and you want to convert these all to p lines, and there's reasons you would want to do that, because I have my reasons as well. And you run a p-edit and you want to say multiple, you can select multiple line segments or arc segments and convert them all to polylines. Just say yes, and then you get polyline options for all of them. And each one of these is now an actual polyline. So you can do a multiple. I'm going to do a p-edit on just one. And here are my options. I've got open, join, that's if I want to add segments, width, which can be the width of the entire polyline, edit vertex, which allows me to edit specific vertexes, fit. I'm going to be honest with you, I've never used fit, and I think these have more to do with like splining, which is like smoothing out curves, because that's what doing a spline does. If you hit the spline option, it's going to attempt to kind of turn them into a curved option, and you can see now I've got control vertices that control that spline. It's my original P-line shape, but I'm able to convert it or modify it with these are now like control vertices for that spline. And I imagine that fit works in much the same way. There's my original points, but I guess instead of being inscribed inside that polyline shape, we are now circumscribed along that polyline shape. So if you don't know the difference between circumscribed and inscribed, take a rectangle and then put a circle. If the circle is inside, then my rectangle is considered circumscribed. If if it's inside, the rectangle is circumscribed. If the circle is outside, touching the points, then my rectangle is considered inscribed. So my points here, if I were to connect them, would be something like that, which would make my polyline inscribed inside this object. So let me go back and do that. So that was fit. Decurve is whenever you're splining and you want to turn it back into a polyline. You can't really decurve this because it's already been decurved, but you can spline it and then decurve it. Line type generation, this has more to do with line types. So do I have any active line types in here? Not really. I'm going to load a line type in here real quick, like the hidden line type. And say OK. And I'm going to put this on hidden, and I may not be able to see it because of my line type scale. So I'm going to put my line type scale at 5, 10. 10's good. Okay. As you can see right now, and this probably for another day, but as far as line types go, but I'm going to show you this briefly. As you can see right now, every corner is defined. When the dashes get to the corners, they are broken in a way that shows the corners. If you need the dashes to be exact lengths no matter what, because the length of this dash is not the same as this dash, you can use, and same thing over here, these two are not the same as this one and this one. You can change what's called the line type generation. So we go to a P edit, we click this, and we change line type generation to be on, and you can see what happens is my corners aren't really defined in the same way. They don't have that like nice, even, defined corner anymore. The line type changes. It kind of, what it's attempting to do is attempting to maintain its exact, dash length. So if you need those clearly defined corners, which in most cases I find myself needing, I'm going to want to leave that line type generation set to off. And then I get those clearly defined corners. And you can see what's happening as I move this. It's just attempting to fit them in there and always have that defined corner. Not an option you should have to mess with very often, but just so you know that it is there. Reverse, this is probably more prevalent in something like this one. And even still, actually, no, reverse is probably the order of your vertexes. So let's do the little experiment here. Let's look at vertex 1. This is vertex 1, so that means vertex 2 should be here. Okay, so I'm going to do this. I'm going to put with a height of 6. Okay. That was too big. Let's put this at 2. Okay, this is 1, and we're going to copy here, here, and here, right? This will be 2, 3, 4. All right, that's what we did. So if you look, we're on vertex 1. This is vertex 2, vertex 3, vertex 4. Let's reverse this. Okay. Now let's look at vertex 1. And there's vertex 1 where 4 should have been. Vertex 2 at where 3 should have been. And so we're reversing the direction of the vertexes. This can be important if you're expecting the vertexes to be edited in a certain order. And it's important to know the direction of the vertexes, because there's one option that you can get that you don't get through the pedit command. Actually, there's a couple options, but one of those options, or the 3 options you don't get, are vertex editing, which you can get by mousing over the vertex. You can remove the vertex, add the vertex, or stretch a vertex. You don't need to really ever do stretch, because you can stretch it by simply clicking it. It's the same thing. If you were to do this and go to stretch, it's the exact same principle. So there's no reason to actually select stretch, but you can add a vertex. When I add a vertex, it's going to add the vertex in the direction that the vertexes are heading. So if you need to add a vertex, say I need to add another point out here, that's great, it works in this direction. But let's say I needed to add a vertex right here. Well, actually, let's reverse this so our numbers match up. All right, so this is now 1, 2, 3, and 4. Let's say that I need 2 to actually be here, and this becomes 3, and this becomes 4, 5, and 6. Okay. See, I'm going to put a point here and here. If I go here and attempt, let's say I go here and attempt to add a vertex, it's going to put it in this direction. So if I were to start here, this isn't going to work because it's wanting to move to the next vertex in line. In this case, we're going counterclockwise. So if I try to put this vertex down here, we're going to cross. So I have to use this one. Same thing here. I have to use this point because we want to go counterclockwise. So add vertex from this direction. Okay. Reversing the direction changes the direction at which you can add vertexes. Similarly, you can just remove vertexes and I can get that original shape back. So just keep that in mind when adding vertexes. I have had to do that. I've had to take a polyline and I could have redrawn it, but maybe it was a complex polyline and it was much easier for me to just add a vertex in line. The downside is you won't really know what the direction of the polyline is outright. You're just going to have to select it, see where your vertex 1 is, and start kind of mousing upward, clicking upward here so you can see the direction that they go. So you know, if you know the direction of your polyline, you know the direction that you can insert your vertex. Okay, so that's running through all the options of p-edit. Width, again, you can change the width manually through the p-edit command and say something like 1, or even easier, come over here and just say global width of 1. If you need to change the width of a segment, keep in mind what vertex you're on. So if I do a start segment of 1 and an end segment of 1, it's only going to do it for that one segment. You saw though when I had it at 0, it was tapered. You can draw a polyline tapered, even when you're drawing it. For, like let's say I have this thing going this way, and I want to put a width of 3 and an ending width of 0. It's going to be tapered. Maybe I can make a little arrowhead or some other symbol. It makes a triangle. It's got a delta looking thing. And as long as I make this, it will always be 3 inches at the start and 0 inches at the end, or whatever variation that I need. You can do it in that way. And it will keep doing that. It'll do it for that segment as you start to draw these things. The next segment is back to 0. So if I want to do it again, I could, or whatever. Okay, so that's our widths. We've gone through all the options. Now you've seen me, and anybody who's watching this who may already know a lot about this and is looking to glean some things may have seen me do a few lines like this, and then turn my ortho on, or oh snap. Let's just close it. There. I realize I'm doing lines, not polylines. I'm getting confused. So they have individual line segments. And like I said, anybody who's watching me do this has seen me run through the p-edit command, convert it into a p-line, and then join it. And, that seems so long if you already know about the join command. The join command absolutely can take line segments by just typing in J for join and just joining all the segments together. What we've got is a polyline. So super fast, right? Why did I just start with that? Because it's important that you know about the p-edit join command, because the regular join command can also make 3D polylines. What are 3D polylines? They're like basic polylines, except they can travel in the z-axis. So let's say I have a 3D, actually, look at a regular p-line with a width of 0. All right. You'll notice that even if I'm pointing upward, even with my ortho on, it will not go into the z-axis like a line would. Now, a line will let me go up in the z-axis. You can see I can go x, I can go y, and I can go z. So I can do this and this. Okay? P-line won't let me do that. That's really, really important to remember, that a polyline is restricted to its plane, no matter what. This is really handy because if you happen to be working in 3D in a different plane, know that your P-line will never snap to a lower object. Okay? If I draw this up here and I snap here, it's always going to be in the same plane. okay? It's locked. And the same thing happens when you change your UCS. If I change the UCS to the front, this might be disorienting with the grid on, but if I change my UCS to the front and I do the exact same thing, if I go up and click on this, it might look like it's going towards it. It's tapered upwards, okay? But it's still locked into that 2D plane, okay? So really important to remember that because 3D polylines don't work like that. 3D polylines work like lines. Oops, 3D poly, okay? 3D polyline can go x-axis, z-axis, y-axis, however they need to, and they're still a polyline. But they do have limitations. They no longer have a width, okay? 3D polylines can be good for certain things. For example, if you want to do an extrusion, let's say I want to do a circle, and I want to do an extrusion along a path or a sweep. I'll do an extrusion along a path. My extrusion now followed that polyline. So it's like a regular extrusion, except it followed the polyline. 3D polylines can have their vertices filleted. So if I wanted to do a fillet of like, I don't know, 12. Maybe not. I could have sworn they could be. I think you can, but it's done in a different way. And I may be thinking, I also happen to use CADWorks as well, and I'm thinking of their pipe run tool, which can do that as well with fillets, and I could be getting that confused, so my bad on that one. But extrusions can be run alongside those 3D polylines. Now, why is this important? Well, it's important because let's say that I have a line that does this, right? And let's say that somehow this end got turned upwards a little bit. If I go do a join, it still looks like a polyline, but it is now a 3D polyline. So you have to treat it as such, which means you lose a lot of your polyline functions. If I go do a p-edit, I don't get the same options. I get some options, but I don't get the same options. I definitely don't get width. And line types may or may not work the same way. See, there's no line type at all. I try to do a match properties, and I'm not getting, it's set to hidden, but it's not showing as hidden. So you may not see that lines are at different elevations when you're in a top view. So if you use that join command, it's possible that your polyline may get converted into, or what you think is a polyline, your 2D, your line segments may get converted into a 3D poly. One of the easiest ways to tell that this has happened compared to regular polyline is you lose the access to the center grip. A regular polyline will have a center grip that you can grab. 3D polylines do not. So, and I'm not trying to school you here too much on 3D polylines. If it's outside of your league, if you don't need to know that kind of stuff, but I don't want you to accidentally create a 3D polyline and wonder how you got there when you just use the join command. In most cases, if all of your work is in 2D, this should never be an issue for you, and join should work for you like 99% of the time. You never have to worry about that. But if you notice that it's not acting the way you want it to, you're not getting the width options, you're missing that center grip, it's very likely if a 3D polyline, go to your properties menu and look. If it's 3D polyline, there's your problem. Okay, and then that just means that you have a portion of it that is elevated above the rest of it, and you need to fix that. So, okay. Multiple p-edit. Why would you want to do a multiple p-edit? Well, your mileage may vary with a multiple p-edit. One of the things that I do in my line of work is I make grading, walking surfaces, like metal grate. And when I make a metal grate, I use, here's a quick way on how I do that. Actually, I did a CADWorks tutorial on how to make realistic grading, but it works like this. Let's say we're going to go to hatch, right? And I'm going to look for the grate. Let's look for this pattern. Great. There it is, great. Okay. So, and I'm going to choose it by object, and I'm going to set the scale to 32. That's good enough. Okay, I'm going to explode this. Now it becomes a series of individual lines. What I want to do is I want to convert these to polylines. And the reason I want to do that is that I want to give them a realistic thickness. So I'm going to do polyline multiple, which, by the way, you can also just type in MP-edit, and it does the same thing. And you can say convert lines and arcs to polylines, yes. Enter an option. I'm going to do a width, and for me, grading width is going to be 3/16 almost all the time. Now what I've got are line thicknesses, and they look hollow because I'm at a 3D angle. On top, they look solid, but as soon as you go to an angle, they turn into what looks like a hollow line type. And then from this point, I can actually give them a thickness, like I would any other line, of like an inch. And so now I've got what looks to be like a somewhat realistic looking grading. And these are just polylines that I've given a thickness and raised an inch through using the thickness, which is a line thickness is basically taking a line, like any line, like this, and just raising it whatever you need. 4 inches. This becomes a line that's 4 inches tall. So that's one instance. I can give a personal example of why I would want to use a multiple P-line edit. But in most cases, majority of the time, your P-edit and your P-line is going to be much more simple. It's going to be modifying rectangles or just drawing a quick, P-line this or that, or doing a shape like this and then converting it into a polyline that you can then further edit or give thicknesses and things like that too. So I want to say that's probably it. That's, I would say, most of what you need to know for a really kind of in-depth view at polylines. I'm sure there could be something that's escaping me right now, but this should get you through. This is an really in-depth view of what you can do with polylines. They're used almost everywhere. They're just a great way to keep lines organized. If you're able to make a shape and have that shape as a group, a collection of lines that stay together rather than having to manage. If I want to move this, I don't have to worry about just this arc moving. I can grab this object and copy it around as needed, or move it as needed, and it's all a complete object. Highly recommend polylines. Whatever you know that you're going to need to kind of keep that object together, and not have to worry about selection windows. If I have this broken up into individual pieces, if I do a selection window, this is going to get selected, whereas this is not. Same thing like this. I know for a fact this is going to get selected because all of the individual segments were inside my selection window, whereas because this is one object, it was not completely inside my selection window. So it can be great for, like, if you have a really complex maybe border of some type or outline, not accidentally grabbing a segment of that of that border. Maybe just if I'm coming in here and I've got let's turn my thing off, and then we'll do this. I'll close it. If I can come in here and grab this without fear that I'm going to be grabbing a segment of this, I can do that. I can grab all this stuff here and know that I'm not going to accidentally grab a portion of this polyline. So that's definitely a major advantage over regular line segments. So there you have it.